Hi, my name is Alex, and I'm an CTO. I'm a CTO. Yeah. So I'm here to tell you a little bit about how I got here. It all starts about 10 years ago, and I have a little story for you. So about 10 years, I was here in London, just moved to London. I was working in fintech, and it's a story born out of frustration. So my mom was back in Romania. Her roof started leaking, and she needed money. So I thought, that's easy. I'll just send you some here in London, making the big bucks. Here's the thing. So I bank with 4 letters. I'm not going to name names, but it took me 7 days to move money in Romania. I had to explain why I'm moving that much money into Romania. And by the end of it, I lost about 18% in fees. And like all of this to take some of my money and put it inside, well, back then it was still in Europe. It was pre-Brexit. I don't know how it is today. I've never tried since. Because I realized for that transaction, it would have been much cheaper to hop on a Wizz Air flight, deliver cash in person. I could have done it basically in the same day. And for much cheaper than it cost me to send money electronically. So I realized that the way we move money today isn't really seamless, easy, if you're not in the same country. So now, if we're at the same bank, or if we're in this country, I can send you money easy. But what happens if I'm not? What happens if I'm trying to do this globally? What if I'm trying to do this to, I don't know, Nigeria, let alone Romania? So this isn't just broken for me. It's broken for about 1.4 billion people. Sending money should be as easy as sending an email, but it's really not. So if this sounds familiar, if my problem sounds like it's resonating, it's because it's not the first time this happened. This used to be the case where it was slow, it was expensive, and it's fragmented to send data across networks of computers. This is what the internet looked like way back when. I don't know if you remember dial-up internet. I do. Took you 2 to 5 business days to download the movie, and by the time you downloaded it, you didn't really want to watch it anymore. And so we thought, how can you make money movement as seamless as data packets moving on the internet? Because at the end of the day, it's still data packets moving on the internet. So when the internet started, we looked a lot at this. Networks couldn't really talk to each other. You needed coaxial cables to plug in from one computer to the next. Different protocols were competing with each other, down to even different types of cables. And then you couldn't really escape your closed little system, your closed little loop. And then something changed, and now you can actually do all of that. And the thing that changed is people started to break all these rules, all these vendor lock-ins, and they created an interoperable protocol for talking on the internet. It's called TCP/IP. And we thought, what if we could do the same thing? What if we could make payments interoperable? When I talked to my CEO at the time about this, I used to work in PCI DSS compliance. Talked to my CEO at the time, and I tried to explain the power of open source and open protocols. He looked at me like I was crazy, like maybe I had too much ginginha to drink. He was Portuguese. So I started looking for alternatives. I started looking for places where this sounded like a good idea, because it did sound like a good idea to me. So I decided that I wanted to build, instead of building another closed network, another closed system for moving money, or another currency. Crypto was popular at the time, and everybody was selling you on the new token that can move money faster. What if we designed an open protocol for moving money, making financial systems interoperable? And I know what I was trying to do. I worked on 40-year-old systems written in COBOL. Trying to get those things on the internet was difficult, let alone talk to each other. So I thought, what if there's a way for all of these basically accounting ledgers to talk to each other, connecting them the same way the internet connects computers. Of course, I had a lot of pushback from the finance world. I think the first thing I heard is, what about security? Security by obscurity is still a big thing. I truly believe the more people can look at your code, the better it is. The next hurdle was, what about the lawyers? Will they understand? Even if we make it out into the open, will regulators see what we're doing? I don't know. 5 years later, I can tell you, regulators will never get it. Still trying to solve that one. And then the last one, and that's the one where I think I got the most pushback, but if everybody can see that code, they can copy it. What about our competitive advantage? So instead of trying to find a for-profit company, I found an open source foundation that does not have a competitive edge or does not need a competitive edge to try to build a new payment network that relies heavily on open source. And this is how Interledger came into my life. Interledger is an open standard for moving money across different accounting ledgers. I know this ledger in the name, it's very poorly chosen, pre-crypto name, and everybody hears Interledger and thinks crypto. Sadly, half of my job is building software, and the other half is explaining how we're not crypto. I wish, if I got one wish into this world, is I could go back in time to about 10 years ago and make them choose a different name. But the way we did this is by having 3 pillars that guide everything we do and making a lot of strategic choices, a lot of architecture choices, and relying heavily on community and community governance. So the way I can show you this right now is those are the people that are working on Interledger software right now. So we have about 65 working on our core infrastructure, about 50-something working on one of our commercial products, and we've got 30-something people who have influenced and designed the protocol, none of which work for the Interledger Foundation, none of which work for us. All of them random people from the internet, not as random. Some of them work for regulators, banks, and the like. But all of them are building this together. And I know it's not possible if it wasn't open. So first, when we designed Interledger, it works kind of like TCP/IP, very tightly based on it. The only difference really is in TCP/IP, if I send a packet of data and it gets lost, you just package a new one and send it. If you do that with people's money, they tend to get upset. So there's no way to lose a packet of money in the network. It has a self-heal mechanism. But that's plumbing, basically. No developer out there into the world is going to go to their boss and say, let's put this thing in. Nobody will see it. That's going to make us 5%. So we developed something for everyday use. And on the bottom layer sits Interledger, all plumbing, nobody ever sees it. And on the top, we have a shiny new API that everybody can use that does delegated access into accounts, basically allowing you to do payments without a PSP license because it talks directly to the underlying bank without having to make the money move through a third party. We have about 2,000 commits on this piece of software. That we thought was something that we built to see if it works. Turns out everybody else was trying to build the same thing, and if we did it for them, they started using it. And because they wanted it to do more things, they've contributed to it. It's really not a closed vendor map. When we talk to some of the closed vendors out there, I get a roadmap that's 18 months into development. If I want to make the train, I have to make it in about 2 years. For us, it's you go on GitHub, you open an issue, and within 24 hours, somebody will let you know if this is worthwhile or if you have to build it yourself. It's building together financial infrastructure. The other point that we had to work on was the way we actually architected this to make sense in the global financial world. So we have these little connectors that sit next to your accounting ledger in your infrastructure that basically route payments, speaking Interledger. And then we build multiple implementations because multiple financial systems. I think the most popular ones we have today are Rust and JavaScript. I don't know why. I would have bet Java would be the most popular one out there. But those are the ones that get the most developers to interact with, or the most people to work with. And because it's JavaScript, it makes us very popular for adoption. Everyone out there can speak JavaScript now. But the reason why we did all of these implementations isn't because we wanted to tightly control our software stack. It's because we wanted as many people to be able to use it and understand it and trust it because they can see the code. The other important aspect of this, or the important decision we made, is we let everyone have a say in what we do. So we worked through something called request for comments. Every little piece of the protocol that goes out, every little piece of design that we come up with internally actually gets posted online, and people have a set number of let's say, weeks at this point to comment on it before it makes it into production. So today, about 30-something people have voiced an opinion and shaped these specs. But it's not just coders. It's usually operators or standards writers or regulators at some point. And the Interledger Foundation is basically the steward of this global infrastructure for making money move. We try really hard to stay open, transparent, and global. I think we probably have about 60 or so repos on GitHub. All of them except one are open source. The only reason why one of them isn't open source just yet today is because we just acquired a company a few months ago, and their code wasn't really up to our standard. So we spent the last couple of months trying to get that code to not leak secrets anywhere and basically be up to our standard. And I think by the end of the year, we'll have every single piece of code we write out into the public domain. You can see how people have interacted with us over the years. We've been going for a while. I think the end of the pandemic was probably our most popular contribution time, and then conferences like this started happening again. People started traveling. We get less people poking at it, but more engaged contributions. Contributor growth isn't here to tell you how popular we are. It's just how sustainable we are. So I have 60 people writing code for this reference implementation that do not work for me. I have about 5 people that write code for that piece of infrastructure that basically quarterback the community. So I get to 10x my workforce without having to hire for it. I know the talk before me was agentic AI and being an HR department. It's kind of like that. It's a bit like that, but for humans, not agents. And those contributors, they keep growing and growing and growing every year. I mean, it's November now, but last month was a very popular month for us because of Hacktoberfest. We probably onboarded more contributors during October than we do in the rest of the year. And that's not only for one of our repos, that's across repos. I gave you a selection of our most popular ones. Rafiki is a reference implementation. That's basically infrastructure. Nobody ever sees that into the real world. Webnization is an actual product that we developed with the W3C and a bunch of the browser makers. And the request for comments is basically text. So no matter the level of engagement or the level of experience, people can interact with parts of what we do. It's not just for developers. And this sounds like a great idea, right? We see a lot of open source projects out there that have a good story, but then usages that just have the good story. We actually have some real world implementations that use Interledger under the hood. Mojaloop is an instant payment system built for the African market. There's about 6 countries right now running a module loop. It means one loop. And Interledger is baked into it from the start. Because we were open, they could take it, shape it to what they needed it to be, and ship it to the real world. Some other people in this world who have fancy, shiny instant payment systems from CMA, I hope there's nobody from CMA watching this, but who have fancy, shiny instant payment systems that I think when I asked them for a quote, it was about 12 million to give me a test instance. People who can afford a lot of fancy software have actually used this to put in front of that fancy software to give them a lot more transactions or a lot more throughput. We also power payment systems into the global south. We're doing a pilot with People's Clearing House, Cámara de la Gente, that is doing 4.3 million accounts, I think, right now, powering cross-border from the US to Mexico. And all of this sounds very boring, I know, because it's a payment system. Nobody sees what you're doing. What about commercial adoption? What about real humans? What about you and I? So there's this company that thought, what if we made money stream instead of pay? So for every time you watch Netflix, instead of paying them at the end of the year, at the end of a month, what if we could pay them in real time for every second? And they tried to do this on a bunch of payment systems, none of which could really handle the load. And in the year of 2022, the whole country of India did 72 billion payments. In the year of 2022, this company with about 5,000 monthly active users did 70 billion payments. Granted, the payments were the 100th part of a cent, so super small, micropayments basically, or nano payments, how they like to call it. They did this all on Interledger because one of the lucky accidents of building new payment infrastructure in 2020 is that we built it modern, so we can handle about 1 million transactions per second per instance. If you need more, you can spin up a new instance, but at that point, other than these people, I've never seen anyone need 1 million transactions per second. I think transparency wins, not because it's a weakness, but because for us it's an advantage. Regulators can see the code. Security is strengthened by scrutiny. We do third-party security auditing every year on everything we do. The security auditor is chosen by a bunch of the banks that deploy this into production, so we have nothing to do with it. We pay for it and we incentivize them to find as many things as they can. After they find their things, we fix it and then we release the report out into the open. I think the most I had to pay them a year was about 30K for my security audit. That's how many things they found in about a year. I think the internet won because it wasn't really perfect. It won because it was open. And I think finance or the finance world is going to be the same. This is a shameless plug because we are open source and we're not really about rebellion. It's about building systems. But we build systems out in the open. So if you want to help us build this system, I'm here all day and tomorrow. You can find us on the internet. Help us build it better. Help us learn from all of you. And if you have a couple of agents into the mix, maybe we will use those as well. And I think that was my short and sweet. Thank you.
We have plenty of questions, so it's good to know that you're here for the day if we run out of time, if we can get them up. Well, who is adopting this protocol in production environments? I think that came in quite early. I know you answered some of that, but I don't know if you want to add a couple more.
So, yeah, right. Who's using this in production? So we have, well, here's the thing. Technically, anyone could use it, but practically, because we built this as a payment network, it's only regulated financial institutions. So to join the network is decentralized. You don't have to come to a central entity to hook you up to the network. You just have to make your software talk Interledger. Whether you do that yourself or you use the reference implementation, up to you. building that yourself may take 6 months. Putting the reference implementation might take 7 days. And then you find somebody on the network to connect your implementation to. And that's where the licensing comes in. We have money servicing businesses, EMIs, electronic money institutions, PSPs, traditional banks. We even have Forex exchanges because they don't actually serve any of the accounts, but they do the cross-border, cross-currency aspect of the protocol.
The next one, how does this compare to open banking?
Right, so we call our API open payments because we thought open banking was a lot. I mean, I've been here, I've had to work on open banking. I still remember when the aggregators were a thing. Most people don't really need open banking. Most people need to just make a payment, send money. That's why you have Stripe that's popular. Stripe doesn't do banking or open banking. So we restricted what is open banking to the smallest subset that would allow you to do one simple thing, make a payment. And that's what we did. We basically took a very small subset of open banking. We made it just about payments. So you can't check balances. You can't check transactions. You can only instrument payments out of accounts, right? Those instructions go directly to the bank, and the bank is the one that checks balances. The bank is the one that figures out if you can pay this human or not and sends out the money.
Next one. So how do you think the recent emergence of X402 micropayments will affect you or require integration?
This is recorded, and we're not all friends here. But if this wasn't recorded and we were all friends here, I would tell you to look at X402 closely in the next 6 weeks, and you'll see a new payment network emerge in X402. But the idea is interoperability isn't about being the one protocol to rule them all. So we connect into major networks. X402 is one of those major things where we take Interledger to the edge and we do last mile delivery on them. We do the same with instant payment systems. We do the same with core banking systems. Interledger is just like plumbing. The same way when you get a new computer, you're always connected to the internet. When you have a new accounting ledger, or a new network, you connect it on the Interledger.
All right, I think that's us in time. So thank you to Alex.
Thank you so much.